Welcome to Global Virtual School students. This is your first year class. I am Dr. Jalbano and the topic for today's discussion from chapter 3 is effect of bonding on properties of the compounds. And in this topic we will discuss the effect of bonding on ionic compounds and covalent compounds. We will discuss as a comparison of the effect of bonding on properties of these two types of the compounds, ionic compounds and covalent compound. First one is the solubility. Solubility means dissolution of something in solvent. That is like solubility of what is the difference between solubility of ionic compounds and covalent compound. If you have asked the question to compare the solubility, then you can write the points as I am discussing here. Ionic compounds are soluble in water. Usually most of the ionic compounds are soluble in water, and most of the covalent compounds, they are soluble or dissolved in non-polar organic solvents. Non-polar organic solvents, for example, benzene is a liquid that is a non-polar and organic solvent. Ether is also a liquid and non-polar organic solvent. So covalent compounds, mostly covalent compounds, they are soluble in non-polar organic solvents, and most of the ionic compounds, they are soluble in water. And ionic compounds are usually insoluble in non-aqueous solvents. So those solvents that do not have water, they do not contain any portion of the water, they are called non-aqueous. For example, benzene, ether, this is ethanol, this is a non-aqueous. So most of the compounds, usually ionic compounds, they are insoluble in non-aqueous solvents, and most of the solvent covalent compounds, they are insoluble in water. So but some of the very few of the covalent compounds, they are soluble in water. Now I will discuss how the solubility process occurs. First of all, I will take the example of sodium chloride. This is the table salt. When you take the sodium chloride as solid in water, you know there is a solution of sodium chloride. You have observed this usually at home. Sodium chloride is dissolved and disappear in water. What happens? Basically, this is the process of solubility. And what is actually the reason sodium chloride dissolve in water? You know, sodium chloride is formed by electrostatic force of attraction between sodium ion and chloride ion. The energy that is required to break these ions, this is called lattice energy. And this sodium ion, when a water molecule, like you know, due to difference of electronegativity, oxygen bears partial negative charge, hydrogen bears partial negative charge, and when it comes in contact with sodium ion or any positive ion, there are some force of attraction between negative end of the water molecule and this positive ion. Similarly, other water molecules also surround in this way, and this is called the hydration energy. So when the water molecules, they form the bond with the ion, this is called hydration energy. Hydration energy. When hydration energy is equal or greater than lattice energy, hydration energy is greater than or equal to lattice energy, then there is the solubility. Why? Because in lattice energy is required, that is compensated with the when a bond is formed between a dipole, in this case water, and an ion. So when the hydration energy will be higher, that will be used to break this lattice energy, break to this sodium and chloride ions. Then there the process of solubilization. In case hydration energy is lower as compared to lattice energy, then there will be no solubility of the ionic compound. Similarly, its other part is surrounded by the water in this way. Positive end of the water and this negative ion, they form some bonding. Similarly, other water molecules also surround in this way, and they form the bonds. In this way the solubility process occurs. and this particularly, this is called ion dipole force of attraction. We will discuss in some other lecture. Ion dipole force of attraction. In this case, ions are sodium ion or colloidal, and in this case dipole is the water. So due to this process, their solubility occurs of the ionic compounds. But in case of ionic compounds, in organic solid like benzene, they do not have enough energy to break this lattice energy. That's why they remain insoluble in organic solvents. Now come to the solubility of the covalent compounds. Covalent compounds, they can dissolve they can be soluble in organic solvents because they have enough energy to overcome their bondings and they form the bonds. But some of the organic compounds are still soluble in water. For example, ethanol, C2H5OH, because those organic compounds, those have some oxygen or nitrogen group, they form the hydrogen bonding with water. So due to hydrogen bonding, this is hydrogen bonding. So due to hydrogen bonding between water and the other organic compounds, they are solubilized in them, and that's why few of them are soluble in water but mostly are insoluble in water. Hopefully solubility process is clear. Now come to the second point, that is the stereochemistry of the compound. Basically stereochemistry of the ionic compound and covalent compound is that the arrangement of the atoms in space. You know, ionic compounds are formed by the electrostatic force of attraction between cations and anions. So they are non-directional and they are rigid because they are just force of attraction and they are fixed at the point. While in case of compounds, covalent compounds, they are formed by sharing of the electrons and they are directional and they are non-rigid. Bonds can be break and they can form the bonds to some other atoms. So that's why ionic compounds, they do not have isomers, but covalent compounds, they show the phenomena of isomerism. For example, dimethyl ether, dimethyl. So two methyl groups, CH3, and this is oxygen and this is CH3. This is called dimethyl ether. And other is ethanol. Ethanol is CH3 CH2OH. And if you focus on this, in this compound total 2 carbon, 6 hydrogen and 1 oxygen, and in this case total 2 carbon, 6 hydrogen and 1 oxygen. So they have same molecular form. Basically this is just rearrangement of the dimethyl ether and ethanol. If this one of the hydrogen comes here and CH2 form the bond with CH3, then the ethanol is formed. So this is just rearrangement of the bonds. So these are non-rigid and directional. That's why they show the process of isomerism, while ionic compounds, they do not show the process of isomerism. What about the reactions? Kinetics. Kinetics means speed of the reaction. Ionic compounds, they have their reaction kinetics is fast, while covalent compounds, their reactions are slow. Why? The reason is because when a reaction takes place between ionic compounds are already in an aqueous form. In aqueous, they are positive and negative form, and they just form the new bonds. While in case of covalent bond, first there is breakdown of the old bonds, then making of the new bonds occur. That's why covalent compounds, their reactions are slow, while ionic compounds, their reactions are fast. Now I will explain you with the help of example. For example, silver nitrate, this is a solid. Sodium chloride, this is also solid. Solid do not react with each other. So first of all, there are solutions of silver nitrate. When silver nitrate, that is solid, and it is dissolved in water, it forms silver ion and nitrate ion, and you can write it aqueous. Similarly, when sodium chloride is dissolved in water, it forms sodium ion and chloride ion. So you have already there aqueous solutions. So when these silver ion and nitrate ion means silver nitrate. These are aqueous ions. And with sodium ion and chloride ion, so these are like aqueous solution, means aqueous ions. When they react to form sodium with nitrate and chloride with silver, they just form new bonds, silver chloride. White precipitates are formed in the reaction mixture, a white solid, and then there is also formation of sodium nitrate. These are ions and this is in the form of solute. So in this process just only making of new bonds occur. So process is fast. While in case of covalent compounds, first old bonds are break, then new bonds are formed. How? Let the example, this is the acetic acid. This is like CH3, C double bond OH. It reacts with ethanol, C2H5OH, and they form these ethyl acetate and water. How? Because in this case, first this bond is broken, then this bond is broken, then broken. They form OH and H. They form new bonds between hydrogen and OH, and they form water. So old bonds are broken. There is breaking of old bonds, two old bonds, then formation of one new bond and other, and due to this form bond with this one, so new bond is a second one, new bond is formed. So basically this involves breaking of some old bonds, then formation of new bonds. So process is slow. Well, in case of ionic compounds, there is only formation of new bond. There is no breakdown of the previous bond. While in case of covalent compounds, first there is breaking of old bonds, then there is formation of new bond. That's why these processes are slow. Hopefully reaction kinetics is clear now. Now the fourth one is the density. Density of ionic compounds and covalent compounds. Density is, students, mass per unit volume. Let you have equal volume, two containers of equal volume. One contains this like 1 gram, or one contains more mass inside it like 10 gram. So which have the low density and high density? Because this is mass per unit volume is higher as compared to this mass per unit volume. So it has high density, while this has low mass per unit volume, so it has low density. Both have the same volume, but within the same volume, one has greater mass, one has lower mass. So which have the mass per unit volume higher, that will have the higher density. Which have mass per unit volume low, that have the low density. So ionic compounds, they have little higher density. Why? Because ionic compounds are formed by electrostatic force of attraction between cations and anions, positive ion and negative ion, and these ions are very close to each other due to force of attraction. That's why their volume decreases and their density is higher. While in case of covalent compounds, bonds are formed due to electrostatic force of attraction between the atoms. So atoms have at some distance to each other, they have bond lengths like single bond, double and triple bond, and there is not much decrease in the volume. That's why they have lower density as compared to ionic compounds. So hopefully density is clear. Now we have different types of solids on the base of their force of attraction. First one is the molecular solid, as it is name says molecular solid, a solid that consists of molecules and in which there are present intermolecular forces of attraction like hydrogen bonding, dipole-dipole forces, London forces, ion dipole forces. We have the example of solid water. Solid water means ice. Ice is a molecular solid because in ice there are all molecules of water like this one, H2O, 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 H2O. They are very close to each other, and in between water there is hydrogen bonding. So hydrogen bonding is a intermolecular force of attraction. Similarly, dry ice is consist of carbon dioxide. So in dry ice there are carbon dioxide molecules, lot of carbon dioxide molecules. They are held together to dipole forces. That is also intermolecular forces. And so this is a molecular, the solid which consists of molecules, lot of molecules, that is a molecular solid. Similarly, metallic solid, it consists of metal bonds and metallic bonds and metallic force. In metals, the valence electrons are loose to escape the atoms. That's why they have positive and negative charge, and then they held together through force of attraction. For example, silver, copper, gold, iron, sodium, and lot of more examples. They are metallic solids, and the force between them is the metallic forces, and those bonds are called metallic bonds. Now we have example of ionic solid. Already you know they are formed due to electrostatic force of attraction. Electrostatic force of attraction is between positive and negative ions. For example, sodium chloride, in sodium positive and chloride ion, calcium chloride, potassium chloride. There are a lot of more examples that are ionic solids. Then we have covalent network solid. Covalent network solid means those solids, giant solids, in which there is present a covalent bond. For example, diamond. In diamond, I will discuss this in the next lecture. Each carbon is attached to the other carbon through a covalent bond. Each carbon is attached to the other carbon through a covalent bond like this, and this form a giant structure. So that is called covalent network solid. Similarly, graphite, each carbon this is also an allotrope of carbon. Each carbon is attached to the other carbon through a hexagonal shape, and these are attached in layers. This I will discuss in the next topic. So this is a covalent network solid. And now we have the question: melting point, boiling point, heat of vaporization, heat of sublimation. First, you know what is melting point? The temperature at which the solid melts. The boiling point, the temperature at the liquids boil, or their external pressure becomes equal to the internal pressure, vapor pressure of the liquid. Heat of vaporization, heat required to vaporize a compound. Then heat of sublimation, heat required to convert a solid direct into its vapors, or from vapors to solid back on condensation, on heating, on cooling. So of ionic compounds or electrolyte compounds is higher as compared to covalent compounds. Argue means discuss it, because you know ionic compounds are formed due to electrostatic force of attraction that are stronger as compared to covalent compounds that are formed due to sharing of electron. So more force of attraction, more bond energy, and their melting point, boiling point, and other heat of sublimation, vaporization will be higher as compared to covalent bond, because those are weaker as compared to the ionic compounds. So you can discuss with the reference to the different examples, and also you can mention their boiling points and melting point. Like water has boiling point 100. And diamond, if you take the example of diamond, it has but this is a giant molecule. Well, sodium chloride, it has very high melting point. So you can discuss ionic compounds with examples, their different enthalpies, and ionic covalent compounds with examples and their enthalpies. So this was all about the effect of bonding on properties of compound with reference to their solubility, stereochemistry, reaction kinetics, and density. And we have also discussed the few types of solids, and in detail we discuss in our next topic. We will compare between metallic solid and covalent network solid.